Hello, my name is Taylor Nelson, and I'm an assistant specialist working with Mark Lundy in grain cropping systems. In this presentation, I'm going to be talking about nitrogen management for California malting barley. Barley production in California has decreased greatly over the past 75 years. At one point, there is even more barley harvested in California than wheat. Today, there are fewer small grains grown due to a large number of high-value competing crops and other economic factors. That being said, there are more breweries in California than any other state, with more than 1,000 craft breweries operating as of October 2019, many of which wish to differentiate themselves by brewing local or California-grown materials. There is a disconnect, though, between the malting barley grown in the field and the malting barley being brewed in these breweries, and that is the malt houses. Currently, there are only a handful of malt houses in California with a very limited capacity. These malting facilities are vital to turning malting barley grown in the field into a product that brewers can use to make beer at the many craft breweries throughout the state. There's interest in growing malting barley for these malt houses, as they offer an approximately 1.5 to 4 times the price premium over feed or forage barley. This price premium comes with a stipulation, though. The malting barley must meet a high quality standard. One of the most important parameters in malting barley quality is protein. For two-row all-malt craft brew, malt facilities want to receive grain with 9 to 10.5% protein in order to be able to consistently achieve extract and production quality requirements. Some contracts allow barley with up to 12.5% protein, depending on the facility's ability to blend barley from different sources and their diversity of end products. If the protein is too high, there is lower amounts of starch and less extract for the brewer. The malting process is also slowed. On the other hand, if protein is too low, this results in insufficient enzymes for fermentation, which is absolutely essential for making beer. Achieving the protein requirement can be difficult, and often there are large portions of grain that was grown from malting barley that is rejected and forced into a lower revenue market. In part, this is due to the wide diversity of agroecosystems in which malting barley is grown in California, ranging from upland rain-fed sites with little yield potential to lowland irrigated sites with more deep, fertile soils and higher yield potentials. There's also fall-planted barley in places like the Sacramento Valley, while barley is typically planted in the spring in places like the Intermountain region. There are also variable amounts of rainfall, as shown in the figure, and heat, not only across different locations, but also across different years. That being said, price scenarios make prioritizing the protein above yield a clear economic decision. Malting barley that meets protein requirements results in higher gross income compared to the commodity price of feed barley. It's important to check contracts for the penalty of not meeting protein goals. In some cases, barley that does not meet protein specifications may be rejected and forced into the lower revenue feed market. The chart shown here shows example outcomes in gross revenue based on 2018 feed barley prices when yield is maximized at each site type versus when achieving protein within the malting quality range of 9 to 10.5% is achieved. The figure is based on 6 site years of nitrogen trial throughout California from 2015 to 2018. In order to achieve protein requirements, it's also important to calculate your crop's nitrogen needs before fertilizing and not apply more nitrogen, even at pre-plant, than a crop will take up. Excess nitrogen often leads to protein above the recommended levels. You can estimate nitrogen needs based on the expected yield and the protein goals, as shown here. It's also important to test soil and account for any residual soil nitrogen before adding more fertilizer. Many other environmental and management factors interact with nitrogen and thus protein, including variety, seeding rate, and water availability. Two-row barley varieties generally require less nitrogen and result in lower protein than six-row varieties. A relatively high seeding rate of around 1.1 million seeds per acre is recommended for quality malting barley. Adjustments should be made to seeding rate so that more seeds are planted in poor growing conditions. Drought and heat stress tend to lead to higher protein as well. A shorter grain fill duration and time to senescence caused by varietal choice, heat, or water stress typically result in lower yield and higher protein. Terminal drought-related stress, something that is common in rain-fed fields in California, is thought to reduce starch accumulation while increasing protein. It is not recommended to apply a nitrogen fertilizer after the tilling growth stage, as more nitrogen is allocated to protein than yield the later this season it is applied. If an in-season application is a possibility, consider putting in a nitrogen-rich strip, as shown, at planting, and using it to inform whether the crop will respond to an in-season nitrogen fertilization and tillering. When you have determined that a nitrogen application is needed, make sure that nitrogen is applied as urea or ammonium sulfate before significant rainfall or irrigation to ensure incorporation and reduce volatilization. If applying nitrogen below the soil surface at pre-plant, do not place nitrogen too deep, as plants may not be able to access nitrogen early in the season when vegetative growth is occurring. All in all, there is a wide range of potential grain yield and protein outcomes across different locations and years in California. Nitrogen fertility is the #1 factor that growers can control to manage their protein and hopefully have good economic outcomes. I'd like to thank everyone shown here. If there are any questions about the information presented, please reach out. Thank you.